Alright, it's John here again, and we're going to move on to number 6 of the Clojure Koans, all about functions. Alright, let's get started. Up at the top, let's start our REPL. Okay. Up at the top, we are going to define a new function called multiply by 10 with one argument n, and it will return 10 times n. Alright, so let's go ahead and define that function by executing it in the REPL. And you see down here that we now have our handy multiply by 10 function. We are going to define another function called square with the argument n, and it multiplies n times n and returns it. So let's define that. And we got that down at the bottom. Okay, so if we call the function square with the argument 9, then we should get 81. Good. Functions are usually defined before they are used. Fair enough. Multiply by 10 with the argument 2 should give us 20. And it does. But they can also be defined inline. Okay, so here we have an anonymous function with the argument n, and we're going to multiply 5 times n. So now we have this function that's called in the here because it's the first value in this list with the argument 2. So the function is 5 times n, and then we're going to call it where n is 2, so it will end up being 5 times 2. That gives us 10. Good. Okay. Or using an even shorter syntax. Okay, so that's the same example as above, except instead of this function here, fn, we use the shorthand pound. So the function is times multiply 15 times the argument, and then we're going to use that function because it's the first value in this list, and the second value is 4, so it'll be 15 times 4 or 60. Good. Even anonymous functions may take multiple arguments. Okay, so we have that same shorthand notation, except now we have arguments 1, 2, and 3. And we're going to add those together, and then we will call that function that we make with the arguments 4, 5, 6. So we're going to add 4, 5, and 6. So 4 plus 5 is 9 plus 6 is 15. Good. Okay, so here we have arguments can also be skipped. So we multiply 15 times the second argument, and then we call that with arguments 1 and 2, so it'll be 2 times 15 should be 30. Good. One function can beget another. Okay, so here we go. We're going to define a function with no arguments that will do something. And then we are going to call whatever got returned by that definition with the arguments 4 and 5 and get 9. Okay, so obviously what we want to do is add 4 and 5. But in between there, we need to make another function that will add 2 arguments, which is something like this. Function, we'll say argument A and argument B, and it will add A and B. And here is where we have a lot of nested parentheses, so I think that looks like the right depth, and that is true. So we made a function that returns another function, and then we call that function. Okay, functions can also take other functions as input. Alright, so we're getting into higher order functions here. Okay, so we have a function f, and we're going to call f on 4 and 5. Okay, so the easiest way to do this is to use our Lisp knowledge to say that plus itself is a function. No. We can't do that. Let's do a function plus 1 and 2. Oh, yeah. It's 4 and 5 makes 20 and not 9. So we are multiplying here. Shouldn't do these late at night. True. Alright, so let's back up. Here we define the function multiply 1 and 2, except we really want to just multiply. So multiply is a function itself. So we can just pass in that function to this function, which takes a function as a parameter and applies it to the arguments here, 4, 5, and gives back 20. I don't know why they tricked us and changed it from 9 to 20. Okay. Higher order functions take function arguments. Okay, so here we go. We are going to say that we want to define a function that takes a function as an argument, which multiplies its argument times itself. So here we go. We're going to make a function which we call and it will take a function f and it will apply that f to 5 and we will call it with this function that gets created here. Alright, so we made a function with an argument of a function, and then we call that function with 5, and then we pass it that function. Alright, that worked out. Great. Okay, but they are often better written using the names of functions. Alright, so wouldn't it be easier to not make this anonymous function and pass it in, but instead just do the same thing. Okay. There we go. So instead of that non-is function, we just pass in square. Alright, great. We did all about functions and we looked at high-level functions, and that was a little bit confusing, but hey, we made it through. So thanks for watching.